Problem 13, explain why the function f of x equals 4 cube root of x squared minus 4 does not satisfy Rolle's theorem on the interval -1 to 1. Well, I'm just going to first of all write down the three conditions for Rolle's theorem. Number one is that f is continuous. Number two is that f is differentiable. And condition 3 is that f of -1 would equal f of 1. The y values at the endpoints would equal each other. So let's start. You could start at really any of them. I'm just going to start at it being continuous. Okay, if I look at this, I just basically need to see, is there anything that I can't plug in for x? I am concerned a little bit with the square root, because I don't want a negative inside of the square root. But if you'll notice I have x squared inside of the square root, no matter what I put in for x, I'm going to get a positive number when I square it. So there's no worries about that one. So f is continuous. All right, to find out if f is differentiable, first of all, I need to take the derivative of that. So I'm going to rewrite f as being 4x to the 2/3 minus 4. And I'm going to take the derivative. If I bump my 2/3 out front, that's going to become 8/3 x to the -1/3. And then minus 4 is just 0. If I rewrite this, this will equal 8 over 3x to the 1/3. So I was able to take the derivative, but can I always get an answer for my derivative? And I would say that when x equals 0, I get an undefined answer. So f is not differentiable. So I would say f is not differentiable at x equals 0, and that is in the interval from -1 to 1. So that is my place. That's why Rolle's theorem does not hold. Okay, I would, if I tested 3, if I plugged -1 into each of them, I do get 0, so that actually does hold as well. So number 2 was the one that caused us not to be able to use Rolle's theorem. Problem 14. Suppose c of x equals x cubed minus 20x squared minus 30x, where x is measured in thousands of units. I'm going to underline that right now. What production level minimizes average cost? Well, if I'm looking for a minimum, I know that I need an equation, then I'll take the derivative, and then I'll set equal to 0. So that's what I'm going to do. Average cost is equal to c of x over x. So my average cost is going to equal c of x, which is x cubed minus 20x squared minus 30x all over x. And I do notice that x will go into each of those, so I'm actually going to divide an x out of each part. So my average cost will equal x squared minus 20x minus 30. So I have my equation. The next thing that I want to do is to take the derivative. So the derivative will be 2x minus 20. And then the last thing I'd like to do is set the derivative equal to 0. And when I do that, I will get x equals 10. So when it says what production level minimizes cost, how many units? Well, since x is measured in thousands of units, this will be 10,000 units. So try to, when you read through the problem, don't just go right to the chase. Read the words, and when I saw thousands, I knew I'm going to have to do thousands of units on that one. Okay, problem 15. Determine whether the function y equals 3x cubed minus x plus 5 is even, odd, or neither, and then explain my answer. So first thing I'm going to do is check for even. And I know to check for even, I'll replace x with negative x. So I'm going to get y equals 3, negative x cubed minus negative x plus 5. And then simplifying this, I'll get negative 3x cubed plus x plus 5. And I notice that that does not equal my original, so no, it is not even. So now I'm going to check for odd, and when I check for odd, I'll replace the y and the x with negatives. So negative y equals 3, negative x cubed minus negative x plus 5. And then I'll get negative y equals negative 3x cubed plus x plus 5. And then I'm going to divide by, or multiply by -1 to get rid of my negative y. So this will give me y equals 3x cubed minus x minus 5. It almost matches, except for this says plus 5 and this says minus 5. So that will not work either. So this function is neither. And my explanation will be, I'm not going to say because when I replaced the x's and the y's, it didn't work. I'm going to say, why did I do that? When I was testing for even, I was testing for y-axis symmetry. And when I was testing for odd, I was testing for origin symmetry. So I'm going to say the function does not have y-axis symmetry. and it does not have origin symmetry. All right, 16. If f of x equals 5x squared minus 3 and g of x equals the square root of 2x, find f of g of x. All right, first of all, we're going to start way inside of the parentheses with g of x. I know that g of x is equal to the square root of 2x. So now I'm going to be finding f of the square root of 2x. So that means I'm going to go into the f function. Wherever I see an x, I will put the square root of 2x. So I'm going to have 5 square root of 2x squared minus 3. Okay, and if I simplify that, the square and the square root cancel each other out, so I'm just left with 5 times 2x minus 3. And then if I simplify that, I will get 10x minus 3. Okay, problem 17. Find an equation of the line that is parallel to the line 4x minus 3y equals 7 and passes through the point 2, 5. Well, okay, parallel is a key word, and find an equation of the line. If I want to find an equation of the line, my answer is going to somehow be in the form y equals mx plus b. All right, if I know something is parallel, it has the same slope, so I need to find the slope. So I'm actually going to solve this for y so that I have a slope. So I'm going to subtract 4x from both sides. So I'll get negative 3y equals 7 minus 4x. I'll then divide all parts of my problem by negative 3. So I will get y equals negative 7/3 plus 4/3 x. So my slope is 4/3, and since the line is parallel, I know that my slope is also going to be 4/3. So now I'm ready to do y equals mx plus b. I know my y value from above is 5. My m I just found was 4/3. My x is 2 plus b. Now working this out, I get 5 equals, if you don't remember how to do this, put a 1 underneath the 2. Just multiply straight across. It gives me 8/3 plus b. Now to get b by itself, I will subtract 8/3. Okay, if you don't remember how to do this, get a common denominator. 5 as a common denominator would be 15/3. So 15/3 minus 8/3 will be 7/3. So my answer is going to be y equals 4/3 x plus 7/3. Okay, number 8, find any horizontal asymptotes. Justify your answer. All right, if you've been studying your flashcards, you should remember that horizontal asymptotes occur where the limit of x approaches infinity. So that's what we're going to be looking for. Okay, when we find the limit as x approaches infinity, we compare the degrees of the numerator and denominator. So I'm going to look at the degrees right here. Ooh. I do notice that the degree is bigger in the bottom than it is in the numerator. So I know that that gives me a limit of 0. Okay, so as long as I find the limit as x approaches infinity with 0, my horizontal asymptote is y equals 0. And when it's said to justify your answer, I have a horizontal asymptote of y equals 0 because the limit as x approaches infinity is equal to 0. It is not because the degree of the numerator is less than the degree of the denominator. That was a tool that I used to find the limit. Okay, problem 19. Find the limit analytically. Okay, first of all, if we just try to plug in 0, which we should always do, if I try to plug in 0, I get 4 sine of 0 over 0. Sine of 0 is 0, so I just get 0 over 0, which we just cannot do. So I need another way. We do have a theorem that tells us that the limit of as x approaches infinity of sine x over x is equal to 1. So I'm going to use that, which means if it says sine of 2x on the top, I need it to say sine of 2x on the bottom. So I'm just going to rewrite this here. So in order to get this to say 2x on the bottom instead of 3x, we're going to multiply by 2/3. But whatever I do to the denominator, I also have to do to the numerator. So up top, 2/3 times 4, again, is going to be 8/3 sine of 2x over 2/3 times 3x is 2x, right? And then from here, the limit of sine of 2x over 2x is 1. So 8/3 times 1 is equal to 8/3.